Okay, we are going to continue with this, just kind of solving some various problems. I think if I can get your attention this morning and I can get you to zone in, I think you'll be encouraged because we've solved more challenging problems than this one. And so, probably, if you've been learning over the last 4 or 5 days as we've been going along, um, you know, I think you'll be encouraged by this one and say, oh, this is getting easier. From my feedback from talking to the class, th- I think people are picking up this chapter a little bit better than they were picking up the methods. Maybe that's just a broad observation of mine. I'm getting a lot more positive feedback. Um, it's also worth noting that we got a pretty good study group going on with Scott and a bunch of people in the class, and so I saw that yesterday, and I was really encouraged by the hard work that a lot of you are putting in. So all of you that are attending that study group, just because you were there yesterday doesn't guarantee anything. Obviously, you got to put in the hard work, and that's one day's worth of hard work. And let me just say, I appreciate that. So I'm encouraged by that, and keep that up, and that should pay off. Um, so this one's called Shirt Demo. We're making these shirt objects with auto-implemented properties. And it has a method where you can pass different number of shirts to that method. And so let's get to it. Yes, let me share my screen. And I don't think this one will take very long. Let's add a new project.
How's your day? How's your morning?
My morning is going all right. How about yours?
I'm getting a new job.
All right. Hey, that's good.
I'm about to be working at Microsoft.
There you go. Congrats. Yeah, that's a stepping stone, right? Now you're working a technical job. At least you're in the industry, and it might be retail, but at least it's technology in retail. So that's a good step.
Best of luck with commission runs.
I'll be doing cashier.
Oh, okay. I thought you were like on
Commission
floor.
rates just come in by themselves.
There you go.
I thought you were on floor because that one's commission.
So we're going to start off by adding a class. Public class shirt. Problem says add auto-implemented properties for material, color, and size. These, again, are very common in C#, these things called auto-implemented properties. Two things to remember about auto-implemented properties. Number one, you do not have to make the backing field, aka the instance field. When you make an auto-implemented property, the instance field is created automatically for you. Number two, the thing to remember is it just has to be, there's no extra rules. When you have an auto-implemented property, it means you could put anything into the data and pull anything out of the data, right? There's no constraints on the data. Anything can go in and it comes out. Okay, so no extra constraints or rules on the data. This is my favorite hotkey in C#, or by hotkey, code snippet, you would say. I'm going to type in the word prop. I'm going to hit tab twice. This brings in a property that is auto-implemented. Of course, you have to fill in the blanks. What is the data type of the property? Well, for material, color, and size, material is going to be a string, color is going to be a string, presumably size, the word large or the letter L, maybe a char, but you could also go string. So we'll do string, string, string. So to take it back to my code snippet, I'm going to hit prop, tab, tab. I'm going to change the data type to string. I'm going to hit tab twice again. It's going to put me onto my property, which is going to be called material with a capital M, Material. Then I hit enter twice. I'm going to hit prop, tab, tab. I'm going to hit string, tab, tab, color, enter, enter, prop, tab, tab, string, tab, tab, size, enter, enter. I now have three auto-implemented properties. It says also this is the tricky part that you'll have to remember from the chapter on methods. Includes a display method, kind of like a toString, in which you can pass a different number of shirt objects. And so methods can accept parameters. Those parameters can be like ints, they could be doubles, they could be floats, or they could be reference types, such as your objects. So you can make a method that as a parameter, it accepts a shirt, a single shirt, or with a comma, 2 shirts, or with another comma, 3 shirts. Okay, but my question to all of you is, how do I make one method where I could pass it a different number of shirts? What was that way that we learned in the method chapter to do that? So here's a method called display, and what goes inside these parentheses is a parameter. I know if you guys stop and think about it. Yes, Trey. Params. And so this display method can take 1 shirt object, 2 shirt objects, 3 shirt objects. It could take an array of shirts, if you will. It can take all sorts of inputs, right? So we talked about overloading methods and making them flexible, but this params keyword, now what we don't know is how many shirts will come in. We don't know if it's 1 shirt or 10 shirts or 1,000 shirts. And so since we don't know, we'll go ahead and loop through. Now, let's see. A display method, which you could pass a different number of shirt in successive method calls. And so what I'll do is I'll return a string that's been concatenated with all the shirt information all into one big string. Kind of like a toString returns a string, this display method will return a string. And so I'll say string return string equals empty string. I'll loop through for each shirt. Now, this may be confusing. Look at this. For each shirt, and shirts. There's 3 things going on here. We have an iterator variable that changes every time through the loop. That iterator variable is a data type of shirt. The identifier with the capital S, the identifier is shirt with the lowercase s. We could call it shirt S if you wanted to. Inside of our array called shirts. And then I'll say return string. This is the hard part of this problem. I'm concatenating a string value to include the shirt information. Let's see. This shirt's material is, you use the property here, material, and I could say this green shirt, this green shirt's material is cotton and a size of large. How about this large green shirt? This. And then what we do is we return the return string. So we loop through all the shirts. We concatenate one string together. We build out this big string with all of the shirt information. And there we go. Now, let's demonstrate that with a button click and a label. And button display shirts. Let's have a results label. Auto size to false, and just kind of. Now I also, just like I do on my two string, I'm going to put in a line break so that each shirt is displayed on its own line. Label result. There's no text by default. So let's just demonstrate this display method a couple of different ways. So I'll say shirt. My shirt is new shirt. Remember, I'm not using the constructor here. I'm using the object initializer. When I'm putting the data in these curly braces, I'm using the properties. And so this is called an object initializer. You know, size is large, color is green, material is cotton. And then label result.text equals my shirt dot now it brings up an interesting scenario where I see the use of a static method. The way I'm calling this, there's two types of methods, and we haven't touched base on this yet. There are instance methods, which is what we have here. So that in order to call this method called display, I have to create an instance of a shirt first, and then I use that instance, and in this case the instance identifier is my shirt, and I say my shirt dot display. But notice that this method is supposed to accept as an input a shirt. And so I got the identifier here. So this is a case where you might want to use something called a static method. So I'm going to add in the keyword static here. And then I'm going to get this. It says size is not null here. An object reference. So we would use s dot size to get through the loop. That was actually a mistake that I already had. I need to use s dot material, s dot. There we go. Okay. So now that we have a static method, again, I want everyone to pay attention to this. This was a concept that was not covered in the methods chapter, but it should have been. You have instance methods when you don't have the keyword static, and then you have the other option is static methods. And they're called differently. So an instance method, for example, I would say shirt s equals new shirt, and then I would say s dot display. Okay, and this is an example of creating an instance of an object on line 19, and then using that instance to call the method. That's AKA an instance method. Okay, you have to instantiate an object to call that method. There's a whole nother category of methods that you guys have used that are not instance methods. Okay, the other category of method that you guys have used are what are called static methods. Okay, Here's an example of that. You've all used the math class, math.floor, math.abs, math.pow. Have you not used the math class somewhere in your code? Somewhere along the way? A couple people shaking, yes they have, right? There have been examples where you didn't have to instantiate an object to call a method. Instead, you mark a method as static, and you call static methods differently. Static methods are called by class name dot method name. So you don't have to create an object. Instead, class name dot method name. Static methods are oftentimes called utility methods. They're called utility methods because there's just like one less step to calling the method. It's a little bit easier to call the methods. It's just class name dot method name. And so you could put a lot of functionality into methods inside of a utility class like the math class. The whole reason the math class exists is to add utility to the people who use it, and the coders and developers who use the math class. So static methods are a whole separate category of methods that we haven't really hit on yet until now, because we came across a problem where I had a display method that was instance, but it didn't make sense to make it instance. It made sense to make it static so that you can pass in your instance variables. You pass in the instances of shirt, your objects, your shirt objects. So I'm going to mark this method as static. Now watch how I'm going to call this differently over here. Now I call it by class name shirt dot display. See, this display method now accepts some variable number of shirts, right? I can pass it a single shirt object, right? Now keep in mind, display returns a string. That string is going to go into the label. Okay, so useful knowledge there on static methods, which is a good reason why we're doing these demos. Now if I run shirt demo and click the button, there we go, the large green shirts material is cotton, right? And of course I could pass it two shirt objects. Your shirt is new shirt using an object initializer. Size large, color red, blend, I don't know. I don't really know too many shirt materials. So I've got my shirt and your shirt, and now notice display, it can take one shirt object. Now in this case, we're passing it two shirt objects. So that works. We can pass it an array. So let's have an array of shirts. Oops. So we got an array of a bunch of purple shirts. Let's put a semicolon at the end. And let's pass it my shirt, your shirt, and class shirts. Now, turns out pretty flexible, but it cannot accept like. Turns out that doesn't work. If you're going to pass it in an array, it has to be the only value. So you could pass it individual shirts, 1, 2, 3, 4, 5 at a time, whatever. Or in this case, you can pass it the array of class shirts, which in this case, all my class shirts are the same. There's 1, 2, 3, 4, 5 of them. 1, 2, 3, 4, 5 of them. Just out of tinkering, I want to make a list of shirt. Class 2 shirts is new list of shirt. And here in my list, just make them all green for the heck of this. And put a semicolon. So now we have a list of shirts. And let's pass in my list. And yeah, cannot convert a list into individual. So our params array does not work with a list. Now you could do a public static string display. You could overload this list of shirt called shirts. List of capital S. And it's basically the same thing, and now it does accept a list of shirt now that I overloaded it, right? So now I can accept a list of shirts, and class 2 shirts would call that particular overloaded method, and there's our green list of shirts. Okay, so a few things that I forgot were in that problem. That were needed to solve it. The main thing on this one, the main new thing, was the introduction of static methods. The main thing on static methods is that they're called differently. You call static methods differently. Instead of creating an instance, you use the class name dot method call. Any other questions? All right, we have a lab day. Let's get to work.